We are intimately familiar with the fury of a thunderstorm. The ominous charcoal skies, the torrential downpours, and the jagged, blinding forks of lightning that strike the earth. It is a primal display of nature's power, one that has terrified and mesmerized humanity since the dawn of time. But what if I told you that above the violent tempests, completely hidden from human eyes, an entirely different kind of storm is raging? A silent, ghostly light show occurring at the very edge of space. Welcome to the mysterious world of transient luminous events. For the better part of a century, commercial airline pilots flying at high altitudes over the Pacific Ocean would cautiously share stories in darkened cockpits. They whispered of massive, crimson flashes leaping upward from the tops of storm clouds into the blackness of the stratosphere. They called them upward ghosts or rocket lightning. But for decades, these accounts were written off by meteorologists. Science dictated that the weather stopped at the troposphere. The upper atmosphere was supposed to be a quiet, empty void. The pilots' reports were dismissed as optical illusions, reflections on the windshield, or the active imaginations of exhausted aviators. Then, on a dark night in the summer of 1989, a team of scientists from the University of Minnesota were testing a low-light television camera. They accidentally pointed it at a distant thunderstorm over Lake Superior. When they reviewed the tape, they saw something impossible: twin pillars of light shooting upward from the cloud tops, spanning tens of kilometers into the night sky. The myth was suddenly, undeniably real. We now know these magnificent structures as red sprites. The name sprite was chosen specifically for its mystical, fairy-like connotations, because these phenomena are as elusive as they are beautiful. If you were floating 60 kilometers above the Earth, a sprite would look less like a lightning bolt and more like a colossal, luminescent jellyfish. They are staggeringly huge. A single red sprite can stretch 50 kilometers top to bottom, and span across a volume of space larger than a small European country. Their blood-red tendrils reach down toward the clouds, while their sprawling, hazy crowns brush against the ionosphere, the very boundary where Earth ends and outer space begins. But how does a sprite come to be? The trigger is actually a rare and incredibly powerful type of lightning strike down on Earth. When an exceptionally strong, positive, lightning bolt strikes the ground, it instantly drains a massive amount of electrical charge from the storm cloud. This creates a sudden, violent imbalance in the electrical field above the storm. The atmosphere violently snaps back, creating a massive electrical stress in the thin air near the edge of space. This stress accelerates electrons to near the speed of light, smashing them into nitrogen molecules. The excited nitrogen responds by emitting a brilliant flash of crimson light. It is essentially the exact same mechanism that lights up a neon sign, but occurring on a planetary scale. Sprites, however, do not dance alone. The upper atmosphere is a menagerie of spectral phenomena. Consider the blue jet. While sprites form high above the clouds, blue jets erupt directly from the anvil tops of thunderstorms. They are brilliant, narrow cones of blue light that fire upward at speeds exceeding Mach 300, piercing the stratosphere like a cosmic blowtorch. Then, there are the ELVs. An acronym for emission of light and very low-frequency perturbations due to electromagnetic pulse sources. ELVs are arguably the most sci-fi phenomenon of them all. They manifest as rapidly expanding, perfectly flat rings of glowing red light at the very bottom of the ionosphere. A single ELV can expand to be 400 kilometers wide, yet it lasts for less than 1,000th of a second, a blink so fast that the human eye cannot even register it without high-speed scientific cameras. Today, these transient luminous events are forcing us to rethink the mechanics of our planet. They are not merely beautiful curiosities, they are a critical part of Earth's global electrical circuit, acting as a bridge that transfers energy from the churning lower atmosphere out into the cosmic void. Furthermore, we are discovering that we are not alone in this phenomenon. The Juno spacecraft recently detected the telltale signs of sprites dancing in the swirling, violent ammonia clouds of Jupiter. The discovery of sprites, blue jets, and ELVs serves as a profound and humbling reminder. Even in an age of satellites and supercomputers, our planet still holds breathtaking secrets. The boundary between Earth and space is not a dead vacuum, but a crackling, electric frontier, waiting to be explored.